Hi guys! Welcome to this video series, where we will be building an Arduino based robot from scratch. We will then program it, and create different sensor boards to give it functions such as line following, obstacle avoidance and much more. In fact, we could program the robot to do pretty much anything we want. Now let's get started! So, in order to build the robot, what do we need? If you go to my website and follow the tutorial in there, I have a parts list and a list of tools that you will need. First, we need something to mount the components to. This will also act as a chassis for the robot. To do this, we will use a piece of perf board. I will drill holes in the perf board here. This will be for the motor brackets and caster wheel placement. Then we'll need a way to drive the motors. We can't directly drive the motors from the Arduino because they require more current and voltage than we can provide from the Arduino pins. So we use a motor driver, and in this case we will use the LT93D, as these are cheap and meet our requirements. We will attach the N20 motors to the output of the LT93D. Next, we will add an auxiliary connector to break out the Arduino pins. This is where the sensor boards will attach. Now we need to think about adding the brain of the robot, and in this case it will be an Arduino Pro Mini, as these are compact and are simple enough for beginners to program and understand. I wanted to give you the option of programming the robot by either using a USB cable and FTDI converter, as the Pro Mini doesn't have a USB port, or to program it over Bluetooth. In order to program it over Bluetooth, we need to add some extra components, and this is where R1, R2 and C1 come into play. These allow us to use the HC05 to program the Arduino remotely. If you want to learn more about how this works, I have a tutorial over at leap.uk. The maximum current draw from the Arduino's Pro Mini pins is about 100 mA. We will need more than this to power the sensor board, so we will add our own 5V regulator that can handle up to 1.5 amps. All 5V components will be powered from this regulator. Next, we will add the Bluetooth transceiver that will allow us to program the robot remotely, control it via smartphone or computer, and receive telemetry data. We need to get power to the robot, and to do this we will use a JST connector, as it will stop us from connecting the battery incorrectly. For this version I will use a 2-cell LiPo battery, however in a future tutorial I will show you how to create your own battery board that will be USB rechargeable. We will add a cheap speaker so the robot can make buzz sounds. And lastly, we will add a diode to the 5V input of the Arduino. This will allow us to connect the Arduino to a computer via a USB cable without powering the Bluetooth module in the sensor board. Now I have the holes drilled into the board, I will add the LT93D socket. The eagle-eyed of you would have noticed that I'm using an 18-pin socket and I need a 16-pin socket for the L293D. This is because I had no 16-pin sockets, so I used a 18-pin one instead. I have put a bottom-up image to the left of the screen so you can see where the components go looking at the board from the bottom. These images can be downloaded from leap.uk. I also have images looking at the robot from the top. I use electrical tape to hold items in place while soldering. And remember that solder fumes are very dangerous, so don't breathe them in, and ensure that you have adequate ventilation. The orientation of the motor driver is very important. Ensure that the notch is facing towards where the caster wheel is going to, though. Now I'm going to attach the JST connector. It is very important that you put this on the right way round. The positive side is on the same side as the 5V regulator, and the negative side will be on the same side as R1, R2, and C1. Now I'm looking for a suitable place for the 5V regulator. I'm trying to place the components in a way that will make it easier when we interconnect them. Bingo! That looks like a good place to put it. Let's tape it down and solder it in place. Time to add the Arduino. I had a little trouble getting the headers into the perf board's holes. The header for pins A4 and A5 wouldn't go through, so I decided to add the other headers and add the headers for A4 and A5 at the end. See what I mean? Now we have the Arduino attached, we now need to place the auxiliary connector. Ensure that this is lined up correctly, otherwise, the sensor boards won't go on properly. I also connected the bottom half of the auxiliary connector to the Arduino with solder. The pins that I connected was D10 to A3. I will connect the rest later. Next, I'm adding the speaker. I'm now placing the HC05, this will be placed as close to the transmit and receive pins on the Arduino as possible. This will interface with serial on the Arduino, allowing us to control it remotely, program it remotely, and remotely collect telemetry. Next, I'm add C1, R1, and R2. I connect R1, R2 and C1 to each other in accordance with the schematic. The other ends of these components will be connected later. Lastly, I will add the diode. Make sure the negative side of the diode goes towards the Arduino. This is denoted by the line on the diode. Because I incorrectly placed the speaker, I'm now going to move it. Hey presto! These are all the placed components, and you can see that they line up with the picture to the left. Your robot should look the same. This is what your board should look like once all the components are placed. We will connect everything next. Now we're going to start connecting the components together, starting with the motor driver. This is a schematic of the robot, it can be downloaded from elite.uk. These are what we will connect. The blue lines are control signals, The red line is 5 volts, the pink line is 7.2 volts. The yellow lines are ground, and the black lines are the motor driver output to the motors. The pinout for the motor driver can be seen on the right hand side of the schematic, but remember the schematic is from the top down, and we soldered from the bottom up. This means that the D5 pin is on the left when we look at the schematic, however on the robot, the D5 pin will be on the right as we look at it from the bottom up. This goes for all of the pins on the schematic. I will connect the enamel copper wire to each of the motor driver's pins and then route the wire to the correct place. I'm connecting the 4 ground pins here for convenience. I use enameled copper wire as it allows the copper wire to touch without creating a short circuit. However, it can be difficult to work with as you need to melt the enamel off the end when soldering. I'm connecting the 5 volt pin to the voltage regulator's output here. Now I'm connecting the voltage from the batteries. This can be anything from 7.2 volts to 11.1 volts. This is the negative terminal from the JST connector, and this will be connected to the 4 ground pins on the motor driver. Now I'm extending the ground pins to the ground terminal on the voltage regulator. And this will connect the motor driver to VCC, which in this case is 7.2 volts. We need 2 voltages on the motor driver. 5 volts for the logic circuits and up to 11.1 volts to drive to motors. You can see me threading the copper cable that's connected to the motor driver's output. These wires will be connected to the motors. It's starting to look neater now. This is where I connect the control wires to the Arduino, and we will start with D7, D8, and D9. D7 and D8 controls the direction of the right-hand motor, and D9 controls the motor's speed. These pins are now connected to the Arduino. The motor driver is also connected to the 5 volt supply, VCC, and ground. You can also see how the 5 volt regulator is connected to the battery and motor driver. I will now connect the other half of the motor driver to Arduino pins D5, D4, and D3. D4 and D3 will control the motor's direction, and D5 will control the motor's speed. I will connect the motors to the motor driver later. This is what all of the motor driver interconnections look like, including the voltage regulator. Now I will connect the positive part of the diode to the 5 volt supply. In this case I will use the 5 volt supply from the input of the motor driver for convenience. Now I'm connecting the negative side of the diode to the 5 volt pin of the Arduino. This can be used as a 5 volt input or output. I'm now connecting the A4 and A5 pins to the auxiliary connector. These pins are for our I2C bus. I will finish off the auxiliary connector and connect pins A6 and A7. Gosh, I messed that up. Bear with me one moment while I fix it. Even the pros make mistakes. I will connect the 5 volt line and the ground line to the auxiliary connector. The auxiliary connector is now connected, and this is its pin out. Because I'm in the area, I will now connect the speaker to the D2 pin of the Arduino and the negative side of the speaker to the ground line. This is where the Bluetooth module is connected. I will connect the ground, 5V, TXT, and RXT pins. Remember that the TXT pin goes to the RX pin on the Arduino and the RXT pin goes to the TX pin on the Arduino. The state pin must go to the open end of C1. The open end of R1 should be connected to 5V and the open end of R2 should be connected to ground. We connected the other ends of R1, R2, and C1 earlier. Refer to the schematic if in doubt. The junction where C1, R1, and R2 are connected should also be connected to the reset pin of the Arduino. These are the connections from the Bluetooth module to the Arduino. Notice how TXT is connected to RX and RXT is connected to TX. The state pin is connected to C1 that will allow us to program the robot over Bluetooth. Also look at the C1, R1, and R2 junction that's connected to the Arduino's reset pin. I've drawn the connections on here to make it easier to see. I messed up here. I connected the other side of R1 to the 5V line before the diode. This line only has 5V on it when the battery is plugged in, due to the diode. This meant that when I plugged the programming cable into the robot it was put in a constant reset state because 0V was applied to the reset pin. To correct this I removed the red line and connected R1 to the 5V pin of the Arduino. This means that when the Arduino is plugged into the computer 5V will be applied to R1 giving us about 3.7V on the reset pin stopping the Arduino from resetting. I've drawn a blue line from R1 to the negative side of the diode. This is how my robot is now connected and how it's shown on the schematic. At the end of this video there will be a high resolution picture of the robot's interconnections for your reference. This shows how all the components are connected around the C1, R1, and R2 junction. Note that one end of C1, R1 and R2 are connected together. This junction is also connected to the reset pin of the Arduino allowing us to remotely program it. I've drawn in the correct connection for R1 being connected to the Arduino's 5V pin rather than the battery 5V line as explained earlier. That's it, all of the interconnections are complete. All we need to do now is add the motors, caster wheel, and a battery. Before you add your battery I would advise that you double check the interconnections. Here I'm adding the motors. I put some electrical tape over the terminals of the 5V regulator because if these are shorted it will blow up. Once the motors are added, add the caster wheel and attach the wheels to the motor. My wheels are old so I had to hot glue them to get them to stay in place. I ended up using standoffs to make it easier to mount the caster wheel. Well done guys, you should be proud of yourselves, we have made an actual robot from scratch! We will program the robot and add basic functionality in the next tutorial. I hope to see you there!